and we have x squared minus 2x plus 1 equals 0. And this is kind of a strange problem because this actually is already ready to be factored into a perfect square. But let's assume that we don't know that, and the plus 1 could be any number. So if this was just any number in general, we would move it to the other side first. So you'd have x squared minus 2x. I'll leave a space and put the minus 1 over here. Now, I need to figure out my a value. And again, it's always half the coefficient on x. So in this case, a is minus 1. And so the number that I have to add to each side is just a squared. Minus 1 times minus 1 is positive 1. So I'd have to add 1 to each side. And again, this is a strange problem because we just end back to what we started with. So this original quadratic was already factorable into a perfect square. But I just wanted to show you the process just in case you didn't have a strange situation like this. So this expression here is now a perfect square, and it's always going to be x minus half the coefficient on x. So minus 1, and then that's squared. And this is equal to 0. So the number that we'd put in the box here would be negative 1, and this is equal to 0. And you can solve it here. You can square root each side, and in this case, you'll actually just end up with one solution because you're going to be adding and subtracting 0. But if we square root everything, then square and square root cancel. You just get x minus 1. And then you get plus or minus the square root of 0, which is 0. So we'll add 1 to the other side. And 1 plus or minus 0, well, 1 plus 0 is 1. And 1 minus 0 is also 1. So you get the same value for your solution. So this is a repeated solution. And just since this was such a strange problem because it was already factorable, let me show you one that isn't. And we have x squared minus 10x. And I'll write the plus 44 off to the side because we need to find some space here. If this was equal to some value, I could just subtract 44 on each side and remove it. But since it's equal to a function, I'm going to leave it on the right side and just make a space here. So my a value, as always, is half the coefficient on x. So in this case, it's minus 5. So a squared minus 5 times minus 5 will give us positive 25. And just note, the number a squared, it's always going to be a positive number. So you're always going to be adding something to each side of this equation, but your a value can be negative. So we're going to have to add 25, and let me use a different color for that. So we add 25 here, but you can't just add 25 to one side, you have to add it to both. Or you could also subtract it on the same side of the equation. Because really I'm just adding 25 and subtracting 25, and so my net result is I'm doing nothing. And the reason for this is now we can kind of group this trinomial together here, and we can simplify the constants. So with this, you end up with your perfect square. And remember, the a value on the inside is always half this coefficient, so it'd be minus 5 in this case. And you could think about it from factoring sense, that we're looking for, with this number, two numbers that multiply to 25 but add a negative 10. And the only two numbers would have to be the same number, minus 5 and minus 5. And now here we have 44 minus 25, which will give us 19. And so to solve this, you would put minus 5 in there and plus 19 there. Because these are so confusing, let's just do one final question. So let me rewrite it. F of x is x squared minus 6x, and I'm going to leave a space and put minus 60, because we're going to add a number so that we can transform this into a perfect square. And so our a value we know is half the coefficient on x, so in this case minus 3. And so a squared would be minus 3 times minus 3, which is positive 9. So I have to add 9, but I will also have to subtract 9, so that my net result is that I'm essentially adding 0. And I'm not changing the equation. So now I'm going to group this trinomial. And so this is now a perfect square, where the a value is minus 3. So we have x minus 3 squared. And then minus 60 minus 9 would be minus 69. So here we can put minus 3. And here we'll put negative 69. And you might ask, what's the point of rewriting our function like this? Well, you might be able to recognize that this is now vertex form. And so if, let's say, we wanted to graph this function, then we can immediately identify the vertex. It's the x value that makes this expression 0, so 3 in this case. And when you do plug in 3 here, this expression just goes away and you get that negative 69. So by completing the square, you can very quickly find out what the vertex to this parabola is, or this quadratic equation.